In the previous videos, we had a look at how we work on our products and how we store products in the database. Now we are going to work on orders, and the interesting part here is of course that orders are connected to products. So let's dive into that in this video. The first thing I want to do is I want to create a new entity order in orders namespace. It has an ID, product ID for a related product, and a quantity. We have a pretty simple model, where one order relates to one product only. Initialize fields and make them public. Then, the next step, we need a storage to be able to map database rows in our order class. Class storage encapsulates MySQL connection. And the first feature that we are going to implement is creation of a new product. We provide here an ID of the product and a quantity. Make a query with insert. Provide quantity and ID of the product. Then, once the query is done, we instantiate an order. Inject product ID and quantity and build an object. That's it. Method create returns a promise that resolves with an instance of a new order. Now update the controller. Open create order class. Add a constructor and inject a storage. In method invoke, replace this array with two variables, product ID and quantity. Don't forget to explicitly cast them to integers. Call this storage, create, and provide values from the request. Then, once the order is created, we return a promise with 201 status code. We don't have such a response yet. That means that when we create a product, we return 200 response. Oh, let's fix it. Open JSON response and add a new static constructor created. It will accept some data. Inside we return a response with 201 status code. Move back to create order controller, return JSON response created. And also we can fix create product controller. For now, let's return a simple response, an instance of order. Later we will add a better self-descriptive response and remove this dummy response we used previously. For now, in create order controller, we handle only a happy path. In case of errors, let's return an internal server error. Okay, let's find out if it works. Open server.php. Import our new order storage with an alias orders. Create an instance of orders, and while we are here, let's inject it in all orders related controllers. Here, here, here and here. Start nodemon. Open requests file. Let's get a list of products. Get an ID of the product. So send a post request to /orders with an ID of this product. Now here we see, we created a new order. We stored the product ID and we get a quantity of 1. So now we can successfully create new orders. Let's make sure that we can also view all orders by going to our general /orders route. Open the storage and add a new method getAll. Make a select query. We select ID, product ID, and quantity from orders table. Then we need to map the result rows into order object. Use ArrayMap function. Inside the callback, we map each row into an object. Add a new method which returns an instance of order. Inside, map an array into order. ID, product ID, and quantity. And we cast everything here to integers, because the values we receive from the database are strings. Done. Now open the controller getAllProducts. Add a constructor and inject a storage. Inside method invoke, remove a dummy response and return this storage getAll. It returns a promise that resolves with a list of orders. For now, let's return them with 200 status code. As always, in case of error, we return 500 response. And with this setup, we save this and let's try it out by sending a GET request to /orders. And we get back all the orders I did create. Actually just one. So this is now my GET request. Let's work on the response and return more information than just an array of items. As we have previously done with products, create a new namespace output and inside create class request, which will store information about additional requests in the response. It has a type, URL, and an optional request body. Initialize the fields and make them public. The constructor make private. In the response, with a list of orders, I want to see requests to individual orders. So create a new static constructor detailed order. It accepts an ID of the order. And inside, return a request with a GET method to localhost port 8000 /orders/ID. We hide this behind a constant. The request is done. Then create one more class order, which will be a response representation for our entity. It accepts an ID, product ID, a quantity, and an instance of the request. Initialize fields, make them public. Instead of a public primary constructor, create a static one. Name it from entity. It accepts entity and a request. Add an alias for order entity. Inside we map entity attributes into the response. That's it. Now move back to the controller. Import order response with alias output. And let's build a response. Create an array with key orders. Here we map orders into the output representation. And a key count with a total number of orders in the list. add a new method mapOrders. Inside, map a list of orders into responses, each with a request to detailed information of the order. Return output from entity, order and detailed request from this order. Change response data, save this, send a request, and I get this more structured response with more information. The same makes sense for creation of a new object. Input and output class. Here, when we succeeded, we return a response with the key order, and I also want to provide a request where we can get a list of all orders. So create a new static constructor, listOrders. Set type to get and use a basic URL. Done. Finish the controller. And if we try that out by sending a post request to /orders, we see that nice response. Now, if I try to send a string as a quantity, this order will be stored with a quantity of 0. We need to add a request validation here. For orders we have only one endpoint where we persist data, so let's extract a namespace for this use case. Create a new directory createOrder and move a corresponding controller there. Class createOrder inside namespace createOrder sounds too explicit, so we can rename this controller. Okay, now let's add an input class. Add a constructor and inject an instance of server request interface. Add validate method. Add a validator for product ID. We check that the request body contains a key product ID, that it is not blank, numeric, and positive. And set a name product ID. The same validation rules can be used to validate quantity. Copy this and replace product ID with quantity. Then build a composite validator and assert the request body. Add two helper methods to retrieve product ID and quantity. Copy them from the controller. Product ID first. Paste it. Fix request. Then quantity. Copy, paste, and fix the request. Done. Now open the controller and use this new class to validate the request and to retrieve the data that we need to create a new order, product ID and quantity. And with that, let's again send a request with a quantity as a string. And we get nice error messages explaining what's wrong with the input. So this part of request validation works, but we still can face some issues here. For example, what happens if a user decides to create an order with an ID of product that doesn't exist in the database. We get a database error, which is not very friendly. Let's fix it and check that the product exists before we create a new order. Seems that we need two storages here, one for orders and one for products. Let's import them with aliases. And fix the constructor, inject orders and products. Rename two orders. Nice. Now, before we create an order, we need to fetch a product first. And if the product exists, only then we create an order. Inject input and use a product here. Paste, add return. Also, now we need to catch an error when there is no product in the database. Add a new error handler with product not found error. And here we return bad request response saying product not found. Now, before we check this code, remember that we have changed the constructor. So open server.php and inject products in the controller. OK, open requests and let's try to create an order with an invalid product ID. Now I get product not found error. And with that, again, if I do get all my products and fetch a valid ID here, if I create an order with such product, it succeeds. So this works, but we can't store orders for products we don't have, which of course is very useful. Now let's continue. Let's get information about individual order. Inject orders. Then here we return this storage get by ID. Of course, we don't have such method. Let's create it. It returns a promise. Inside we make a select query. Select ID, product ID, and quantity, where ID equals a specified one. Then we map the first received row into an instance of order. If there is no record with such ID, let's throw order not found error. Create it and extend from runtime exception. Done. Move back to the controller and continue chaining. We handle three cases here. If the order was found, we return 200 response. JSON response OK. Otherwise, if there is no order in the database, we return 404. JSON response not found. And in case of an unexpected error, we return 500 response. Return JSON response internal server error. Done. Let's see how it works. At first we fetch all orders. We have this one. Let's try to fetch this order. And if I send this, I get back an order. which is nice, but again, this is not a truly RESTful, self-descriptive response. So let's add some metadata to it. We input order representation as output. Then create a response array with a key order. And for request, we can provide a link where we can delete or cancel this order. Open request and add a new static constructor delete order. Inside we use a delete type of request and a URL to a specified ID. In the controller, use this request as embedded inside the order. And let's also provide information how a user can fetch all the orders. Add key request and provide a request with a list of all orders. Save this and let's fetch an order again. Now I get back a nice RESTful response. So it's time for a delete endpoint. Again, open the controller, inject a storage. Inside method invoke, remove this dummy response and return this storage delete ID. Cast ID to integer and create a method. As always, it returns a promise. At first we check that such order really exists and only then we delete it. Make a delete query for a fetched order. Delete from orders where ID equals a specified one. OK, move back to the controller. Here again we handle 3 cases. Start with a happy path and 200 response. The next 2 responses can be copied from the previous controller, not found and unexpected error. If the order was successfully deleted, we return a 200 response and provide a request with information about how a new order can be created. Create a new static constructor, create order. Send a post request to /orders. And we need to send a body, where we will pass a product ID, which will be an integer, and a quantity, which is also an integer. Finish the controller, save. Now, if we do that, let's again get all orders and let's fetch one. Maybe this one. Now send a delete request to this order. If we do that, the order was deleted indeed. And if I try to get information about this order, it fails, because we don't find it. And that again was a lot of work where we have worked on orders endpoints. Now we can store and fetch that data.